You can do it if you believe you can. Hi, everyone. In this video, I would like to show you the following major topics for math test number 5 in grade 11 math. Number 1, write the equation for each of the following in terms of sine x and cosine x. Number 2, sketch each function where x is in between 0 and 360 degrees. Number 3, solve for x, and we should say x is also in between 0 and 360 degrees. Number 4, word problem. And last but not least, number 5, prove each of the following trig identities. And again, here's what I recommend before we begin. As you're copying it down and you're trying some of the examples on your own, number 1, if you fully understand this, put a check mark. If you have no idea what is happening yet, put an X. And of course, sometimes there's that in-between case where you feel like you know what's going on, but you still need to practice a little bit more. In that case, you can put a question mark. Let's begin. Example number 1. Write an equation for each of the following. So there are two parts. This is 1a, that's 1b. Let's start with 1a. Now, sometimes they're asking you to write this in terms of sine x. Sometimes they're asking you to write this in terms of cosine x. We're going to show you both. So if I start with the basics, what you want to write down is the maximum and the minimum values. Of course, the maximum value means the largest y value. So in this graph, the maximum value is going to be 3. If you look at the minimum value, meaning the smallest y value, it's going to be -1. And once you have the maximum and the minimum value, the rest of this is extremely systematic. What I mean is this. If you think about the amplitude, and again, there's a formula that you can use. The amplitude, of course, is the maximum minus the minimum divided by 2. So in this case, you can think of it as 3 minus -1 divided by 2. Without a calculator, I hope you can see 3 minus -1 is 3 plus 1, which is 4. 4 divided by 2 is going to be 2. So the amplitude is going to be 2. And we're going to verify this in a moment. Now, likewise, if I want to find the equation of axis, there's a formula, and it's the maximum plus the minimum divided by 2. So again, in this case, what we're thinking is 3 plus -1 divided by 2. And of course, 2 divided by 2 is 1. Now, how do we know we're doing this right? So before we keep going, you can go back and look at the y equal to 1 equation of axis. If I draw a horizontal line, you can see how the graph is divided into the top half and the bottom half. So that's a sign that you're doing it right. So this makes sense. And, if you think about the amplitude, there are a couple ways of looking at this. One is to look at the distance from the equation of axis all the way to the maximum. And again, you can tell it's going to be 2. Another approach could be you're looking at the equation of axis all the way to the minimum. And again, the amplitude is 2. Be mindful, the amplitude can never be negative. So in this case, the amplitude is going to be 2. Now, if you want to find the period, what you have to do is take the maximum all the way to the next maximum. And notice how you start from 0 and you stop at 360 degrees. So one period is going to be 360 degrees. Don't forget the formula for the period, which is 360 divided by k. This means when you solve for k, k is going to be 1. Now, for some students that might say, can I look at it from a minimum to the next minimum? That's fine. That's still going to give you 360. For a third student, that student may say, can I pick this point all the way to this point? That's 450 minus 90. That's still going to be 360. And not to overstate this, you can pick any random point all the way to the same random point when it reoccurs. But no matter which case you're looking at, the period is always going to be 360 in this case, which means k is going to be 1. Now, I'm going to grab two different colors for you. One, I'm going to start with the sine function. The second one, I'm going to start with the cosine function. So again, if I think about the sine function, I'm going to write down y equal to, I start with the amplitude, right? So in general, y equals to a times sine of k times x minus p plus q. Now again, depending on the textbook, sometimes we say D and C, a different textbook would say P and Q. Don't worry about the alphabets, just make sure you understand the ideas. So again, In this case, the amplitude is going to be 2, which we wrote from here. You copy sign. Now the k value is 1. So if you like, you can write down 1. If you want to leave it blank, that is fine. Now I'm going to come back to the phase shift at the end. And of course, the equation of axis is going to be 1, which we have right there. Now here's the key. When you think about the sine function, you want to figure out where do we start. So there are a couple ways of doing this. I'm going to show you the best method possible. See, for some students, they're going to say, oh, sine starts here, and there's one rotation. This is not the best answer, but I'm still going to show you. So for some students, they're going to say I have to go right by 270 degrees. So it's a phase shift of 270. So if I erase this, since it's a 1, maybe that student's thinking x minus 270 degrees. And I do want to say, mathematically, that is true. Like that is how you can write the equation for this graph. But that's not the answer. Not the answer in terms of the optimal answer. The best answer is always the answer that's closest to the y-axis. So instead, I'm going to grab a different color. I'm going to invite you to think about it like this. Start here, go all the way to there. Now here's the difference. Instead of going right, which is the phase shift, by 270, you're going to go right by 90. But you're not starting at the maximum, right? So you are going to go right by 90. But notice how you're starting at the minimum. If you're starting at the minimum, what that means is you're taking reflection with respect to the x-axis. So it should be y equal to negative 2, sine of x minus 90, in brackets, plus 1. So that's how you express it in terms of a sine function. I'm going to continue here and rewrite this in terms of a cosine function. Again, in this case, I'm just going to show you one approach, which is probably the best approach to my knowledge. Here we go. If I want to rewrite this as a cosine function, again, y equals to a cosine k times x minus p plus q. Before I continue here, the only difference between a sine function and a cosine function is the phase shift. Everything else remains the same. So again, if I think about the amplitude, it's going to be 2. Again, if I think about the k value, it's going to be 1. You can write down 1. You can leave it blank. If I look at the vertical translation or the vertical displacement, it's still going to be plus 1. Now, the cosine function starts right here at the maximum, and it stops at the maximum. So notice how there's no phase shift. Or you can say the phase shift is exactly 0. So really, I can erase the 1. I can even write down the plus 1 a bit closer, and I write it like this. So again, this is going to be y equal to 2 cosine x plus 1, which is the best way to describe this equation or this graph in terms of cosine x. Example 1b, again, here's the graph. We need to write this in terms of sine and cosine. I would like you to press pause. After you rewrite this in terms of sine and cosine, press play again. I'll be here. Welcome back. So here's the first step, everybody. Always start with the maximum and the minimum value. What do I mean? If I think about the maximum value, it's going to be 2 or negative 2. And if I write down the minimum value, that's going to be negative 4. So again, I write down negative 2 and negative 4. Once you have the maximum and minimum values, the difficult part, it's over because, again, you can write down the equations. Once you write down the amplitude, the period, which will help you solve for k, and the equation of axis, which is the vertical displacement. So again, to find the amplitude, you can take the maximum minus the minimum divided by 2. In this example, that's negative 2 minus negative 4, or minus negative 4 all over 2. Again, this is negative 2 plus 4, which is 2. 2 divided by 2 is 1. You can put a box around that. Likewise, you can find the equation of axis, which means y equals to the maximum plus the minimum divided by 2. So again, in this example, that's negative 2 plus negative 4 divided by 2, which means that's going to be negative 6 divided by 2, which will give you negative 3. Before we keep going, again, I want to direct you to the fact that this makes sense, because if you divide the graph at y equal to negative 3, there's the top half and there's the bottom half. So that kind of confirms this makes sense. Again, to find the amplitude, you're looking at the distance from the maximum to the equation of axis. Or you can say from the minimum to the equation of axis, and in both cases, the amplitude is exactly 1. Not to overstate this, the amplitude can never be negative. Amplitude is always, always, always positive. Again, if you want to find the period, which is 360 divided by k, this is going to be, again, you can grab, for example, the maximum to the next maximum. Or you can take this first point all the way to here. So if you look at the numbers, you're starting at 0 and you stop at 180. So one period, one revolution, one cycle is going to be 180, which equals to 360 divided by k. I hope you can see k must be 2. So far we found the amplitude, we found the equation of axis, we found the k value. We're now ready. So if you start with y equal to a times sine times k times x minus p plus q, y equals to, again, the amplitude is 1. You can write down 1. You can leave it blank. Both are fine. You write down sine. The k value is going to be 2 this time. Now, think about the phase shift. Sine starts at the middle and it ends in the middle. So there's no phase shift to the left or right, or you can say the phase shift is exactly 0. So it's going to be x, and of course, the equation of axis is negative 3. So I'm going to put some brackets there. There we go. That is the best way to describe this graph using a sine function. Y equal to sine of 2x minus 3. If I grab another color, we can rewrite this in terms of cosine. Again, y equals to a times cosine times k times x minus p plus q. If I draw the cosine function in the same color for your reference, it looks like that. Remember, the only difference between a sine function and a cosine function is the phase shift. Everything else is exactly the same. So y equals to a, which is 1. I'm going to leave it blank this time, times cosine. Open that bracket. Again, k is going to be 2 in this case. And notice for the cosine function, I'm shifting it to the right by exactly 45 degrees. I'll say this again, right? You see what's going on here, everybody? If you look at this space and I line this up with a straight line, this is 45, then 90, right? So we're going right by 45 degrees. That's x minus 45 degrees. Again, the vertical translation or the vertical displacement is going to be negative 3. So again, in one sentence, y equals to cosine, open bracket, 2 times open bracket, x minus 45 degrees, close the 2 brackets, minus 3 is the best way to describe this graph as a cosine function. Now, what happens if we go backwards, meaning we go in the reverse sequence? Example number 2, sketch each function below where x is in between 0 and 360 degrees inclusive. So again, in part A, we have a sine function. In part B, with a cosine function. And notice I left the scale blank. So we can kind of set this up on our own. Now, there's so many ways of doing this. We can go back to the mapping rule, which works really well. There's also a faster technique, which we break down into 3 steps. Find a starting point, find out where it stops, find out the max and min, and connect them. So in this example, I'm going to go straight to the fastest method possible. Here we go. Now, the first step is you need to know the starting point. So I need to know, for example, in this graph, I'm adding a 0 to remind myself the starting point means go right by 90 and up, or you can say down by 0. So again, I'm going right by 90 degrees. What does that really mean? If I draw a graph, again, notice the way I think about this. It's really important that you understand the logic. So I go right by 90 degrees, I can set up a scale such that it is 90, 180, 270, 360. And if I take 360 plus 90, that's going to be 450 degrees. Again, I'm beginning with the end in mind. I understand what I am thinking about in the 3 steps. And the first step is I'm going right by 90 degrees. So there we go. Now I'm going to label this in a moment. But the first step is, where does it start? It starts at 90, 0. Now be mindful. It's a sine graph. That's why I start in the middle. For a cosine function, it starts at the maximum or the minimum, depending on the entire function. But for a sine function, you go right by 90 degrees and you stop. So I guess I could label it now. I could say 90, 0 is that first point. Okay. Now the second step is I need to know, where does it stop? So now that I know the starting point, where do I end this? Well, one period in this case, again, look at this value, it's 1. So k is going to be 1. don't forget the period is going to be 360 divided by k, and 360 divided by 1 is going to be 360 degrees. So once you find a starting point, you take that point, you add the period, which is 360. 90 plus 360 is going to be 450 degrees. So again, I'm going to label this point 450 and 0. Oops, 450 degrees and 0. So I know where I started, I know where I'm going to stop. Now it's a sine function, so the midpoint is going to be right there. And again, if you think about this point, this is going to be 270 and 0. Now, the only steps left is step 3. You need to know where's the maximum, where's the minimum. Look at the amplitude. The amplitude is 2. So when you think about the maximum, it's going to go right by 180. You're going to go up by 2. So this is going to be 180 degrees and 2. Now, for your reference, I'll label the side here. This is 2, 1, -1, and -2. So again, when I think about the first minimum, it's going to be right by 360, down by 2. Now, the graph is only asking you to graph it between 0 and 360 degrees inclusive. So I'm going a little bit beyond, which is fine. But roughly speaking, the graph looks like this. I connect it like that and like that. Now, if I need another point, just to make sure I can graph it between 0 degrees and 360 degrees inclusive, I can add one more there. I can even label this 0, -2, or 0 degrees, -2, just like that. Okay, so again, the only step left is you want to label this. So I'm just going to write down y equal to 2 times sine of x minus 90 degrees. Example 2b. Again, I'll read the question to you. Y equal to negative cosine, open bracket, 3x plus 90 degrees, close bracket. Pause the video, try this first. When you press play again, I'll be here, and here's the tip of the day. If you're thinking left by 90 or left by 90 degrees is the phase shift, double check that idea. Is that true? So my hint for you, before you pause the video, put this in factor form. I'll even write it down for you. Put this in factor form. Don't forget factor first. So you can pause the video now, and when you're ready, press play again. Welcome back. Here's the first step. Again, we write this in factor form. So what I mean is we write it in terms of y equal to negative cosine, factor the 3 to the front. So 3, open bracket, x plus 30 degrees. Now, again, there are 3 steps to graphing this. Step 1 is you need to find the starting point. So again, you can add a 0 if you like. You don't really have to, but if that helps you see that you go left by 30 degrees and up by 0, that's great. If you don't need to add a 0 and you can still see that, amazing. So here's the mistake. If you think the starting point is negative 30 degrees and 0, that is not true. This is a cosine function. Normally, a cosine function means you start at the maximum, but there's a reflection here. So you're starting at the minimum. So you go left by 30 degrees. You're going to go down by 1 because the amplitude is 1. So again, I'm going to draw a graph by first setting up a scale for you. Now, when I think about this, we have to graph it from 0 to 360 degrees. So maybe I should extend this a little bit. So let me double this for you. And we'll add more as we need to. So again, all I'm saying is that at this moment, our starting point is going to be left by 30 degrees, and it's going to be down by 1. So let's say this is negative 30 degrees. Let's see if this will work out. So again, this is going to be 1. That's negative 1. That's negative 2. So the starting point is I go left by 30 degrees, and I'm going to go down by 1. Okay. Now that is the minimum. Again, because there's a reflection, this means you start the cosine function at a minimum. If I label this, that's going to be negative 30 degrees, negative 1. Now, what about the next point, step 2? You need to find the period. And if you think about the period, again, the k value, which I'll put here for you, the k value is going to be 3. And the period is given by the formula 360 divided by k. If you think about 360 divided by 3, that's 120 degrees. So 1 Cycle 1 period means you take this first point, negative 30 degrees, negative 1, you go right by 120 degrees. So I'm going to go right by exactly that. That's going to bring us to 90. So 90 degrees, negative 1. Now, what about the other points? Well, the maximum is going to be halfway. So it's going to occur at 30, and it's going to go all the way to 1. And the other 2 points are going to be right there. So again, I am going to label one for rotation with you. The other ones, you don't have to label. You just got to graph it. So for example, here, the maximum occurs at 30 degrees and 1. If I look at the other points, there's a point at 0, 0. And of course, the fifth point in this case is going to be 60 degrees and 0. So if I connect them, one rotation looks like that. Again, I'm graphing beyond what I need to. It's asking to graph between 0 and 360 degrees, but I'm giving a little bit more. Now, if I count all the way to the right, you want to figure out how many times do I have to graph this. So again, if I just plot the points first, just to get a sense of what is happening, it's going to look, roughly speaking, something like this. So I'm going to connect the second and the third. Now again, let's count the number of units to the right. So if I grab the first color for your reference, this is going to be 30. This is going to be 60. And of course, I should label this fifth point. I have 1, 2, 3, 4, 5. Yep. So if I take 90 and I go right by one period, again, one period in this case is 120 degrees. So this will give us 210. Let me go back to the same color for your reference, 210 degrees, negative 1. If I go right again here, so this point right there is going to be 210 plus another 120. That's going to be 330 degrees. So you can see I'm 1 point away. So if I add that last point, that should bring us to 360 degrees. So again, this is 1, 2, 3 rotations between 0 and 360 degrees. And that's how you graph y equal to negative cosine, which I'll label here for you, 3 times x plus 30 degrees in brackets, just like that. We are making progress. Example number 3, part A. Solve for x, where x is in between 0 degrees and 360 degrees inclusive. Now, for these questions, I would like to let you know you can totally get 100% if you're willing to double check. I invite you to double check. It's not mandatory, but I'm strongly inviting you to double check when you're done. Now, here are the steps. Now that you know how to graph sine and cosine, when the question says cosine x equals to 1, the first step is to draw a diagram. And of course, you can label the diagram with the scale. So if I think about y equal to cosine x, it's going to look, roughly speaking, something like this. I start and I stop at the maximum. The minimum's halfway. Those are the other points. So there we go. Y equal to cosine x. And this is kind of what you're looking at on the left-hand side. When it says cosine x, you're thinking about the graph y equal to cosine x. In a different color, when I think about 1, I'm really thinking about it in terms of y equal to 1. So graphically, I'm drawing this line, and I'm asking myself, where do these two lines meet? Where's the POI, the point of intersection, or points of intersection in this case? Again, I can draw some arrows. I could have drawn some arrows for this one as well to show that it continues indefinitely. And just by drawing a diagram, I'm telling you right now, you can see the two answers. Where are the answers? It's going to be at 90 degrees and 270 degrees. Now, this is the most important step, what I'm inviting you to think about. If you choose not to double check, that's fine. But if you do, you're going to feel confident and competent. The best feeling I can offer you. Double checking just means I grab the calculator and I want to know, are the answers right? So for example, if I press cosine of 90 degrees, I grab my calculator, I turn it on, I press clear. Make sure you're in the right mode, degree mode. I press cosine of 90. That's going to be exactly 0 degrees. Now, of course, I just realized I made a mistake here. It says 1, and I graphed this whole thing in the wrong spot for you. So hold on, see? So this is a counter example where I gave you the wrong graph, y equals to 1. It should be up there. Let's try this again. You see, if you don't double check, then you might think you did it right. But now we know that would have been the right answer if it was y equal to 0. Let's try it one more time. Y equal to 1. Here we go. There it is. Y equal to 1. And the question becomes where to the two graphs meet. So you see why it's so important to double check. If we did not double check, we would have assumed those two answers are right. So again, let me try one more time. The answers are 0 and 360 degrees. Let's double check again. I hope you understand the value of double checking because of the mistake. When everything's perfect, sometimes it's hard to value why we double check. I go back, I look at the left hand side, and I need to know if I plug in 0 degrees, what happens? I press cosine of 0, that's exactly 1. That's exactly the right hand side. I do it again, cosine of 360, I get exactly 1. So I know this is perfect now, and I know this with confidence. The best feeling I can offer you. Example 3b, negative 2 sine square x plus 3 sine x plus 2 equal to 0. I would like you to pause the video, try this. Here's the tip of the day. Start with factoring. Put this in factor form. Once you have it in factor form, then solve the two cases, then double check. Again, when you press play again, I'll be here. Welcome back. So here's the first step. Factor negative 1 to the front. So what I mean is if you factor out negative 1 to the front, in brackets, it's going to be 2 sine square x minus 3 sine x minus 2. And of course, you can divide both sides by negative 1. So the negative 1 disappears. And of course, if you factor this a little bit more, you can think of 2 sine square x as 2 sine x times sine x. Your goal is to find the factors of negative 2 that will give you a sum of negative 3. So for example, we can think of negative 4 plus 1, which will give you negative 3, negative 2 times 1, which is going to be negative 2. So again, you can now divide this into two different columns. In the first column, you have 2 sine x plus 1 equal to 0. And in the second column, sine x minus 2 equal to 0. Again, once you get to this step, these are the questions you've done in the previous unit. You're just kind of breaking it down and chunking it into smaller parts. If I start with the last one first, sine x equals to 2. And I'm telling you right now, there are no solutions. Why is that? There are two reasons. Number one, if you grab your calculators and you take the inverse sine of 2, you're going to see either error, ERR, depending on the calculator you're using. You're not going to be able to find the answer. But the second reason, the one I really want you to draw your attention to think about, is the fact that if you graph this, right, if you activate that dual mindset, if you want to know, well, what does this really look like when I draw a graph? In one color, I'm telling you sine x is going to be like this. And if you think about the other side, which is 2, and again, I can draw some arrows to extend this, but if I grab a different color, 2 means y equals to 2. And again, notice how these two lines never meet. So since there's no POI, there's no point of intersection, therefore there are no solutions, and that is the answer in the second column. By the way, when there are no solutions, we can't really double check because there's nothing to check. On the other hand, you can double check the first case. If 2 sine x plus 1 equals to 0, I hope you can see sine x is going to be negative 1 over 2, which is something that you've done. I'm going to go back and draw a diagram for you. Again, think about CAST. Think about the special triangles. Think about the fact that sine is negative. So we're looking at quadrants 3 and 4. Again, sine means opposite over hypotenuse. Opposite over hypotenuse, just like that. The missing side, of course, is going to be negative root 3 and root 3 respectively. If you think about the related acute angle, that's going to be 30 degrees. Now, that's not the answer, of course. The two answers, which I'll color code for you, are in the first color, you want this angle. That's going to be 180 plus 30. That's going to be 210 degrees. If I grab another color for you, the second answer is going to be right there. That's going to be 360 minus 30, which is 330 degrees. Again, how do we know we're doing it right? I'm inviting you to double check. You grab the calculator and you plug 210 degrees in the original, not the second last step, but in the original function. So watch what I'm doing. I'm going to press clear. I'm going to turn this on and press clear. I'm going to press negative 2 times sine of 210 degrees. Don't forget to square this. You might need to add some brackets. Then I'm adding it with 3 times sine of 210 degrees plus 2. When I press equal, I get exactly 0. That's how I know this number works. And you repeat the same process for 330 degrees with the original, not the second last step, but from the original. So I press -2. Sine of 330, don't forget to square that. Add the brackets as needed. Adding 3 times sine of 330. Adding 2. Again, I see 0, which is exactly the right-hand side. So now you know with confidence that your answers are perfect. Example number 4, word problem. A Ferris wheel is rotating at a math fair. The wheel has a radius of 7 meters and makes 1 complete revolution every 16 seconds. The bottom of the wheel is 1.5 meters above the ground. Assume it starts at the minimum at time 0. A. Draw a fully labeled graph of the function for 1 complete cycle. Here we go. Normally, when you graph this, you're thinking about quadrants 1, 2, 3, and 4. That's how you kind of think about it mathematically. In this case, remember, the only quadrant you're focusing on is going to be quadrant number 1 because we're talking about a Ferris wheel. We're talking about something that is 1.5 meters above the ground. So once you understand all that, instead of drawing the 4 quadrants, you can start with something like this. Okay? Now, look at these numbers. Really understand what is happening. So if it starts 1.5 meters above ground, this implies to you that the minimum is going to be 1.5. So go right here, write down 1.5. Of course, this is going to be a function. I'm just going to write down y and x for now. You could really write it in terms of time and height, which we can do as well. You know what? Maybe we should do that. Let's do it now. I was going to do it in 2 steps. We can just do it in 1 step. So t is going to be time. H of t is going to be height. Okay. So again, the fact that it's 1.5 above the ground, that's going to be the minimum. Now think about the radius. The radius is going to be 7 meters. So the amplitude is going to be 7 meters. So if they add 7 and add 7 again, what I mean is this. If I'm adding 7 and adding another 7, 7 plus 1.5 is going to be 8.5, which would be the vertical displacement, by the way. That's going to be the equation of axis. And if you take 8.7 and you add another, if you take 8.5 and you add another 7, that's going to be 15.5. So we found the maximum, minimum, and the equation of axis. Now also remember, 1 rotation is going to be 16 seconds. So if I go all the way here, 1, 2, 3, and 4, this is going to be 16. Divide that by 2. That's going to be 8. Divide that by 2 is going to be 4. 4 plus 8 is going to be 12. So we're setting up a scale so everything fits. And of course, time is going to be in seconds. Height is going to be in meters, just like that. I'm going to go back. Remember, you're starting at a minimum. So you start right there. If you start at the minimum, you're going to stop at a minimum. Again, think about the safety reason. If they get on at 1.5 meters, you're going to come off at 1.5 meters. The maximum is going to be right there. So again, we'll label this 8, 15.5. That's really 16, 1.5. This is 0, 1.5. And you can see the other points are going to be right there. So again, that's going to be 12 and 8.5. That's going to be 4 and 8.5. Once you have the points, you can connect them, roughly speaking, something like this. Again, it's not a perfect diagram, but it's good enough in terms of sketching this function. So it does say draw a fully labeled graph, which we did, 1 complete cycle, exactly. Now, example 4b, write the equation of a sinusoidal function that models the above graph. So we're going to do this choice. I'm going to express it in terms of cosine and express it in terms of sine. You're responsible only for one of them, but I'm going to show you both. So again, if I grab a different color, we know so far the amplitude is going to be 15.5 minus 8.5, so the amplitude is going to be 7. I'm going slightly faster here because you can see it right from the graph. We also know the equation of axis is going to be at 8.5. Again, you can redo this using the max and min like we did in the earlier examples, but since you have all of this, you can go straight into this step. Now, since the period is going to be 360 divided by k, which equals to 16, k is going to be 360 divided by 16. So again, you can do it with a calculator. You can do mental math. It's up to you. But if you leave it as an exact fraction, or if you leave it as a decimal, that's going to be 22.5. Maybe I'll leave it as a decimal for you this time, even though you could express it as a fraction as well. Once you have the amplitude, the equation of axis, and the k value, the hard part is now over. So you can say h of t equals to. Now, I'm starting with a cosine function. Remember, the amplitude is 7. So you put a 7, write down cosine. The k value is going to be 22.5. Don't forget the vertical displacement. That's going to be 8.5. Now, you got to be careful here. Remember, in this case, you're starting at the minimum and you stop at the minimum. So instead of just taking a phase shift, just reflect this. Put a negative sign at the front. Then this is going to be t. Put the brackets. Again, that is the best answer to my knowledge with regard to expressing it as a cosine function. In a different color, of course, you can express it as a sine function. The only difference, not to overstate this, is the phase shift. Everything else is the same. So 7 sine 22.5. Again, 8.5 is going to be the vertical displacement. You can put a bracket like that. Now, for a sine function, you start here. You start in the middle, and you stop in the middle, just like that. So notice how there's a phase shift to the right by exactly 4. So you have to write down t minus 4 in brackets. But other than that, everything else remains the same. Again, in one sentence, as a sine function, h of t equals to 7 times sine of 22.5 times open bracket, t minus 4, close the brackets, plus 8.5. Example number 5, part A. Prove each of the following identities. Now again, there's so many tools that we can use from the toolbox. There's a lot of steps. I'm going to write them on the side for you. So these are the general guidelines. It's not exactly every single step, but I would say the most important 3 steps. So when it comes to proving that the left equals to the right or the right equals to the left, what I'm going to say is this. There are many, many ways. And the one thing I really want to show you in this video is called the move. You're going to see that as step 3. So I'm going to write that immediately. If you're stuck in a trig proof, whether you're on the left-hand side or the right-hand side and you can't go anymore, you basically activate step 3, which is called the move. Now back to step 1 first. Step 1, of course, is you start with the difficult side. Now by difficult, I'm putting this in quotation marks. I just mean the side that looks more complicated. Sometimes it doesn't even matter. So ideally, every proof, you can start with the left or you can start with the right. You can still solve it. But in this example, 5a, you will see that it doesn't really matter. You can start with the left. You can start with the right. It's 50-50. But in general, start with the difficult side. And step 2, of course, is you want to rewrite it, if possible, in terms of sine x and cosine x. So rewrite everything in terms of sine x and cosine x. So rewrite it in terms of sine x and cosine x. I'm going to show you some examples, right? With even on the next page, you can see there's some secant, cosecant, which we'll get to. But back to this one first. All right, so here's how we do it. I'm starting with the left-hand side. Remember, you can start with the right. It doesn't really matter mathematically, but I'm picking the left-hand side. So I go back to the 3 steps, and I can check off step 1, start with the difficult side. I can even check off step 2. We write it in terms of sine and cosine. I did that already. So this is the most important part. I would like you to mentally lean forward. The move. What is the move? The move is the one step you take, and all of a sudden, you're one step away from getting perfect. Look at the other side. Look at what we have right now. We want 1 plus cosine x or cosine theta. We don't have that right now. So let me say this again. On the right-hand side, we want 1 plus cosine theta. We don't have that. The move just means we don't have it. We're going to multiply by what we would like to see. Now, you can't just multiply by 1 plus cosine theta, but you can definitely multiply by 1. 1 means anything over itself. So the move, which is step 3 right now, is you multiply the right-hand side, or I should say you multiply the left-hand side by 1 plus cosine theta divided by 1 plus cosine theta. You're going to see how this whole left-hand side breaks down. Again, let's start with the denominator. If you think about the difference of squares, a minus b times a plus b, that's a squared minus b squared. 1 minus cosine theta times 1 plus cosine theta is 1 minus cosine squared theta. If I look at the numerator, do not expand. Just copy it as is. If you expand, you're not adding value. If anything, you're making it a little bit slower. Now, what I didn't write down are the tools in the toolbox, which I'm going to show you now. You know, I hope you recognize if you think about 1 minus cos squared theta is the same as sine squared theta. And of course, once you can recognize that, you can cross out 1 sine theta from the numerator, 1 from the denominator, and this gives exactly 1 plus cosine theta divided by sine theta, which is the right-hand side. And you're done. And that's how you prove. Example 5a. Great starter, great finisher. Example 5b. Cosine theta divided by sine theta plus sine theta divided by cosine theta equals to secant theta times cosecant theta. Again, I will invite you to pause the video, try this first. When you're done and you press play again, I'll be here. Welcome back. I'm starting with the left-hand side. So again, I'm writing cosine theta divided by sine theta plus sine theta divided by cosine theta. Now remember, your goal is to express this to be the same as the right-hand side. So here's the other idea I would like you to think about. You can write it down if you like. On the right-hand side, there's one fraction, there's one term. Right now we have two terms. So write down in your notes, express this as one fraction. Like you have to bring it as one fraction. Otherwise, they're not going to be the same. So the first step here is we're going to express this as one fraction. The common denominator is going to be sine theta, cosine theta. And what that really means is you're multiplying each fraction by the missing common denominator. So for example, in the second fraction, I'm going to multiply by the missing sine theta by multiplying it by sine theta over sine theta. Likewise, in the first fraction, I'm going to multiply by the missing common denominator. So I'm going to multiply by 1, which is really cosine theta divided by cosine theta. Look what happens. Cosine theta times cosine theta is going to be cosine theta squared. Sine theta times sine theta is going to be sine squared theta. Again, if you think about some of the tools that we have written down from before, cos squared theta plus sine squared theta is exactly 1. And now I can break it apart. So instead of saying 1 divided by sine theta times cosine theta, I break it apart as two fractions. The first fraction is going to be 1 divided by sine theta. The second fraction is going to be 1 divided by cosine theta. And now look what happens. The left-hand side equals to 1 divided by sine theta is going to be cosecant theta. If I look at 1 divided by cosine theta, that's going to be secant theta. And of course, if you really want to rewrite this, you could. You don't really have to. When you're multiplying, there's a commutative law. Order doesn't matter. But if you want, you can write down secant theta times cosecant theta, which is precisely the same as the right-hand side. And that's how you prove example 5b. I hope this makes sense.